Here are the STEM projects that I've decided to do: the catapult, the grabber, and the wigglebot. And the presentation will show the evidence, the mapping to the curriculum, the mapping to the transversal competencies, and the summative assessment rubric. 1A, the catapult evidence. The materials you need are pens, pop sticks, rubber bands, wooden spoons, and super glue.
So now we are going to make the STEM catapult. It should be relatively easy. We'll find out. What you will need is 8 pens, the same type preferably, and you will be making the base with these pens. And you need pens because you need to be able to stick popsicles in between them that way and on the top. And we will use rubber bands, and we'll only need, hopefully, 7 popsicles and 1 spoon as the catapult. And we will need some super glue because we'll be making some A-frames and we need it quite strong to hold it together. So we'll be using some super glue for that and plenty of rubber bands to hold everything together. This is the finished product that we made. We haven't tested it out yet. Pretty much just used 1,000 rubber bands to make sure this thing is solid. We've twisted this around the rubber band in the middle to give it tension so that it will spring up. And where usually we put the A-frame in there, it was too tight, so we managed to just use rubber bands to make it strong. And you can see that's pretty sturdy. So, give it a go. Put that out like that.
1B, the mapping to the Australian curriculum. It's mapped to the science unit. As students can identify and change variables such as the size of the launcher, the size of the projectile, and the tension, repetitions, and the angle of the release. It's mapped to digital technologies, as students can design and catapult and then evaluate the end product with their design and make modifications based on the performance. It's mapped to design and technologies, as students need to select and experiment with appropriate materials and tools for strength and flexibility to make the catapult more effective. And it's linked to the mathematics unit, as students will have to measure the length of the projectile catapulted and the weight of the projectile using the correct metric units. 1C, mapping to transversal competencies. So it's mapped to critical and innovative thinking, interpersonal skills, intrapersonal skills, and global citizenship and media and information literacy. Here are some notable connections: teamwork and collaboration, flexibility and adaptability, ability to critically evaluate information and media content, responsibility and ability to resolve conflict, and application skills. For the summative assessment, the task is students will work in small groups to design, build, and test a catapult. Their task is to modify and experiment with the design to launch small ping pongs with great distance and accuracy. You will be connected with the science and the digital technologies unit and these 2 general capabilities. For an exceptional mark, students are required to have excellent evidence of planning with comprehensive investigatable questions. Experiments are repeatable. Exceptional design of the catapult with comprehensive modifications to enhance its effectiveness. Excellent communication and collaboration with members of their group. Express their ideas and listen well to others' perspectives. And exceptional application of critical and creative thinking. Highly innovative. Second project I did was the grabber. The materials you need are rubber bands, masking tape, scissors, cardboard, ruler, paper fasteners, and string.
So we are going to make the STEM grabber. We have some rubber bands, we have some masking tape, some scissors, some cardboard, a ruler, and paper fasteners, and some string. So what we'll need is to cut the cardboard into 6 pieces, and we'll be using that to crisscross, to grab. We'll be using the ruler as a handle, and we'll be using the string to pull the grabber and to use it, and the string will also be tied to the rubber band so that it will flex. Then the rubber band will be put around the paper fasteners and they will control the movement of the grabber. Now we also grabbed a sponge to put at the end of the grabber, and that will give some friction so it will be easier to grab some objects. So after a bit of trial and error, we seem to have completed it. Decided to change the thicker straw that we had before to a thinner one, and then we put some sponges on the end. Here we go. Wow.
Wait, it's a bit heavy, I guess.
Yeah.
The mapping to the Australian curriculum. It connects with the science unit. The students need to use the grabber and record the data obtained, such as the weight of the objects lifted and the length of the arm extension. Connects with digital technology. The students set definable goals, such as grabbing a certain amount of weight or wanting to reach a certain length with the arm. Connects with design and technologies, as students need to select suitable materials that will make the grabber safe and effective. And it connects with maths, as students can learn about the formula W equals F times D, where work equals W equals work done, F is force, and D is distance object is moved. Mapping to transversal competencies, it connects with critical and innovative thinking, interpersonal skills, intrapersonal skills, global citizenship, and media and information literacy. Some notable connections were organisational skills, ability to learn independently, ethical use of ICT, ethical and intercultural understanding, and creativity. For the summative assessment rubric, for the task, students will individually design and create a grammar device demonstrating their understanding of algebra and engineering. So a big focus on algebra there. So there's connections to mathematics, design technologies, and those two general capabilities. For an exceptional, students need to consistently use the formula without any errors and understand the meaning of the letters. Select great materials and tools to create a highly functional grabber. Exceptional application of critical and creative thinking, highly innovative and creative solutions for the grabber, and effectively uses the iPad to record experiments with them. The last project that I did was the Wigglebot, and the materials needed are to cut the googly eyes of the paper, the DC motor, battle holder with wires, electrical tape, masking tape, Sharpie, 3 to 5 markers, scissors, and pegs. Wigglebot today. I've got my notepad here to make some notes. I've got a cup here to put the googly eyes on and make it unique. Got some paper to make the patterns on. We have our DC motor that we'll need and battery holder. The battery holder will connect with the DC motor to those bits. And to connect it, you will need some electrical tape. And then we have some masking tape to hold it all together. We have a Sharpie to decorate your Wigglebot. And then we have 3 markers as well that we will need to make the pattern on. And of course, we'll need some scissors and we will need some pegs to alter the weight. Okay, so now we've made our little Wigglebot with his eyes and a face, and we've stuck 3 markers on the bottom, but we figured out the more markers you have, the better it will be to balance. We will use the electric tape to stick this on the DC motor weight so that it will move around, and we'll take the lids off. Let's put our Wigglebot there. He's in the middle of the paper, and we'll turn the power on.
Yay! It worked!
Wow, this looks pretty cool. For 3B, mapping to the Australian curriculum, it connects with the science unit as students investigate how energy from the batteries can be transformed to create motion in the Wigglebot and DC motor. It connects with digital technologies as students can use different sized weights, lengths, and height to produce different wiggle effects with the Wigglebot. Connects with design and technologies as students discover how electrical energy can be transformed into movement. Connects with math again as students can work out the RPM of the 1.5V to 3V motor by sticking a pen to it and timing the motor for 10 seconds. Then they can work out how long each motor should run using the equation T equals D/S. Mapping to transversal competencies, maps with critical and innovative thinking, interpersonal skills, intrapersonal skills, global citizenship, and media and information literacy. Here are some notable connections: communication skills, self-awareness, ability to critically evaluate information and media content, ethical and intercultural understanding, and reasoned decision making. The summative assessment. The task for students will work in groups to design and create a wobblebot that effectively demonstrates energy transfer to movement while applying mathematical concepts to calculate the RPM. So it'll connect with physical sciences and mathematics and those two general capabilities. And if students want an exceptional grade, they will have to design and create a functional Wigglebot that is stable and includes a battery holder and DC motor balanced on the top. Effectively calculated the RPM of the voltage motors and T equals D/S with no errors, demonstrating a strong understanding of algebraic concepts. Exceptional application of critical and creative thinking, highly innovative and creative solutions for the Wigglebot, effectively uses the iPad to record experiments with